In this lesson, we're going to be talking about product and quotient theorems for polar complex numbers. Specifically, we're going to be talking about the product. So if you have a polar complex number, it looks like this. We have a radius, you have an angle measurement, but you do have an I, so it makes it a complex number. And how do you deal with two of them multiplied together? So here's the formula for it. So if you have one of them times another one, you're going to multiply the radii together. And when you combine your cosines, you're going to add the angles together. And when you combine your sines, you're going to be adding the angles together. Now, there is a shortcut version of it where CISA represents cosine and I sine of A, and that's cosine and I sine of B. And so it's the same thing. So you're going to add the angles together and multiply the radii together. So if this is our example, and we are trying to put together these two problems, first thing we're going to do is multiply your radii together. Multiply, so it's root 3 times root 3. And then we're going to have CIS of adding those two angles together. So 45 plus 225. And so that's a 3. And then this is cosine and sine of 270. So that's your new polar form. However, you are looking to turn it into rectangular form. So we're looking to turn it into a plus bi. So to do that, we really kind of need a visual to this. So this is a radius measurement, and we are looking to turn it into an x value and a y value, essentially, is what you got going on here. So if you were to graph this, 270 is here, and we are at a distance out of 3. So as far as kind of a polar coordinate or a rectangular coordinate is, we are looking at a 0, 3, but that is our A value and that is our BI. So that is our imaginary, because we have an x-axis is our reals and the y-axis is our imaginary on complex numbers. So we are just looking at a negative 3i as an answer. So that's not the only way to do that. You can look at it as a visual, or you can kind of break this up and do cosine of 270 plus I sine of 270. And so if you plot that point, cosine of 270 is 0, and sine of 270 is, so if you just kind of go back to the basic unit circle, you're at this point. We don't worry about the 3 at all yet. That point is a 0, negative 1. So your cosine 270 is 0 because it's the x value. Your sine of 270 is negative 1 because it's the y value. And it's a negative 1 times I. And then when you multiply that through, that's another way of getting that value. All right, well, we'll do one more. So same type of problem, it just doesn't have the shortcut to it. So we're going to put the radii together. So you're going to multiply 2 times 4 is going to be 8. So 2 times 4. So those two are going to be multiplied together. And then our cosine, we're going to be adding 60 and 150 plus I sine of 60 plus 150. So this is 8 cosine 210 and plus I sine of 210. So to turn this into a rectangular, we need to evaluate these two. So let me just draw myself a visual. 210 is going to be 30 degrees past. So we're looking at a reference angle of 30. And the radius is 8. So when you're in polar, you're kind of talking angles in a radius, where when we're turning it into rectangular, we're looking at x's and y's. Now remember that the x's are real and the y is our imaginary axis. So you need to figure out pieces of a 30, 60, 90. So if you remember that there's a relationship between a 30, 60, 90, that it is x, 2x, and x root 3. So you can go right to these numbers right away, or you can just make this an easy version and say, I just really want 1, 2, root 3. So sine of 30 is going to be 1 over 2. So that's 1/2. Nope. Cosine. Cosine of 30 is root 3 over 2. Now we are in the third quadrant, so that's going to be a negative because tangents are only positive in this. And then plus I, sine of 210, so that's sine of 30 is 1/2. But we are going to be also in the third quadrant, so we have to apply a negative to that. And then we'll distribute the 8. So either you distribute the 8 here, or you make this value an 8 and put these values, kind of just make them appropriate. But distribute it through, and that's going to get us a negative 8 root 3 over 2 minus an 8 times a 1/2 I. So the 1/2 and the 8 are going to go together, and the sign's going to change. So this is going to make a negative 4 root 3 minus 4i. And that is our complex conversion. It's turning it into a rectangular form. So again, if you wanted to do this, if you had made this an 8, then this would have been a 4, and this would have been a 4 root 3. So this is your horizontal piece. So this would have been, or this is your, we'd have to turn it appropriately. So the 30's here, so this would have been your y value. So if that was 8, this would have been a negative 4, and this would have been a negative 4 root 3 if you kind of apply your basic ratios of your 30, 60, 90. And then, so this side would have been half of the hypotenuse, and then this is just the x root 3 to go to here. And so that is your x value, which is this piece, and then your y is the imaginary, which would be this piece. So you can kind of just put it right on your picture, or you can draw up your basic 30, 60, 90, turn that, evaluate those pieces, and then distribute the 8 in. Doesn't matter, they both work. They both should be okay. And that was the product of polar complex forms and also converting them into rectangular forms.